Hello everyone, welcome to the part 2 of our lesson or part 2 of our video lecture. So this one is about Archimedes Principle. I have a question here. Despite weighing approximately 46,328 gross tons, why do you think the Titanic floats? So why, despite its heavy weight, does the Titanic float? Okay, thank you. Because of buoyancy. Or it has something to do with the concept of buoyancy. So when we say buoyancy, yun yung kapag nafe-feel mo na parang inaangat ka nung tubig. 'Di ba pag nag-swimming ka, parang ang gaan-gaan mo. Yan, kasi meron tayong tinatawag na buoyancy. Okay. So what is Archimedes Principle? Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. Ayan. So, parang ang daming nangyayari, ma'am. Pero ganito lang talaga siya. So, say, we have here our fluid. Tapos, meron tayong object na, sige, fully submerged. Fully submerged siya dun sa fluid natin. So, meron daw ditong nag-a-act na upward buoyant force. So, when we say upward, yung direction niya ay pataas. Yan. So, this would be our buoyant force. And then, yung buoyant force na daw na yon ay equal to the weight of the fluid that the body displaces. So, ayan. Ma'am, ano pong weight of the fluid the body displaces? Okay, so for example, kapag, sige. So for example, meron kang timba. You know timba? That means pail or bucket. Okay, so meron kang timba na puno ng tubig. Tapos, naglubog ka ng object dun sa punong timba na yon. So, di ba may umaapaw na tubig from the pail or from the bucket, right? Nung nilubog mo yung object. So, yung umapaw na tubig or nawalang tubig, yun yung fluid na na-displace. Okay? Or yun yung fluid na nawala. So, yung buoyant force is equal to that fluid. Okay? So, aside from the buoyant force, meron pang isang force na nag-a-act sa object and it is always acting on that object regardless if nakasubmerge siya sa fluid or not. So, that force is the, what force kaya? Okay, the weight of the object. Yan. Yan. So, since yung buoyant force ay pataas, that means pinupush niya upwards or pinipush niya against the direction of the weight or the downward force yung object or yung body. Kaya, kayo, parang feeling nyo ay ang gaan-gaan nyo, diba? Kapag nasa tubig kayo. Kasi nga, merong buoyant force na nagpupush sa inyo pataas or nag-help mag-lift ng weight nyo. Okay. So now, pwede ulit siyang i-express mathematically. But before that, babalik muna tayo sa Titanic. So, according to Archimedes Principle, the Titanic floats because the buoyant force is equal to the weight of the ship. So again, yung weight of the object or weight of the body is a constant force that acts on that body. Since lagi tayong may gravitational force. Kasi yung weight ay equal to mg or mass of the object times the acceleration due to gravity. Okay. So, syempre, kung equal yung buoyant force at itong weight of the ship, so, Fb is equal to the weight of the object, that means it is in equilibrium or mag-float yung ating object or ship in this case. Tama? So, that makes sense naman, di ba? Kung equal yung downward tsaka yung upward force, that means in equilibrium sila at mag-float yung object. Now, what do you think will happen if yung buoyant force natin is greater than the weight of the object? So, ano daw, yung buoyant force or yung upward force natin ay mas malaki kesa dito sa downward force. Ano kaya ang mangyayari? Lilipad? Okay, so hindi siya lilipad. Magra-rise lang siya. So, pansin nyo, for example, may beach ball kayo, tapos nilubog nyo sa tubig. Pag nilet go nyo yung force, or nilet go nyo yung hawak nyo dun sa beach ball, para malubog siya, kusang aangat yung beach ball natin to the surface, right? Because yung buoyant force is greater than the weight of that beach ball. Kaya siya aangat or magra-rise. And then pagdating sa surface, magiging equal na yung buoyant force and yung weight of that beach ball, kaya mag-float na lang siya. Okay? Now, what do you think will happen if yung buoyant force natin is less than the weight of the object? Okay, it will, very good. So, it will sink. So, now, you can explain why the Titanic sank using Archimedes Principle. Since na-establish na natin yung relationships between the upward and downward force. Okay. Okay, very good. So, the Titanic sunk because as the water entered the Titanic, yung weight of the Titanic natin increases, making the weight of the ship larger than the buoyant force. Okay? So, dahil mas mataas na yung weight ng ship kesa dun sa buoyant force natin, or less than na yung buoyant force than the weight of the ship, the Titanic sank. Okay. So, the man behind Archimedes Principle is Archimedes of Syracuse. So, he is an ancient Greek mathematician, physicist, engineer, astronomer, and inventor. And he is known as the father of hydrostatics because of his formulations on the principles of buoyancy. So, he is the story behind Archimedes Principle is very interesting. So, dito na, if you know about Eureka, ayan, Eureka. Yun yung parang kapag may light bulb sa ulo nyo. Kasi may naisip kayong something amazing. Ayan. Yan. So, Eureka yung tawag doon. Yan. So, very interesting yung story behind Archimedes Principle. You can look it up during your free time. Pero basically, na-formulate niya yung Archimedes Principle habang naliligo siya sa bathtub. Ayan. So, very funny yung story behind this principle. Okay. Now, we will proceed with the computation involving Archimedes Principle. So, mathematically, Archimedes Principle can be written as this. So, Fb, or the buoyant force, is equal to the density of the liquid times the acceleration due to gravity times the volume displaced, or the volume of the fluid displaced. Ayan. So, this one, hindi yan P class. This is called rho. Greek letter rho. Okay? Ganyan yung siya basahin. Hindi yan P ha. Pag may nakita ko sa solution na nagsulat ng ganyan, mamalian ko yan. Dapat ganyan. Okay. So, ayan. Meron ulit tayong pwedeng ma-derive na formula from the Archimedes Principle. Depende sa kung anong physical quantity or variable yung gusto nating hanapin. Yan. So, for V, ang gagawin lang, ganito lang siya ma-derive. So, meron tayo nitong P, G, V. So, para ma-derive lang yung V, i-divide lang natin both sides by rho and G. Yan. So, cancel, cancel. Tapos, ito yung kalalabasan. Ayan. And then, density of fluid, ayan. Sabi na nga ba? Burahin nyo yan. For the density of fluid, same lang din naman yung magiging process natin. Just divide both sides by GV. Yan. Para makuha natin siya. Ma'am, paano naman po itong buoyant force is equal to W air minus W fluid? Okay, so, ito, yung pag-derive dito is medyo complicated kasi hindi siya manggagaling dito sa equation natin yan. Okay, ready na? Okay, so i-derive na natin siya using this practice problem. So, a solid metal block has a mass of 5.4 kilograms and is completely submerged in water using a thin string attached to a spring scale. The scale reads 34.8 newtons when the block is in water. Number 1, what is the buoyant force acting on the block? Number 2, what is the volume of the block? And number 3, using your answer in letter B or number 2, calculate the density of the metal and identify the most likely material based on a given density table. Grabe, ang daming pinapagawa ng practice problem na to. Yan. So, let's start with number 1. We need to find the buoyant force acting on the block. Yan. So, syempre, we first need to write down the given. So, let me just copy this problem. Yan. So, start with the given. Meron daw tayong solid metal block and it has a mass of 5.4 kilogram. So, that means M is equal to 5.40 kg. Tapos, yung meron tayong spring scale. And then, yung spring scale, minimeasure niya yung weight nung ating solid metal block while it is submerged or nakalubog sa water. So, yung na-measure niya ay 34.8 newtons. Yun yung na-measure niya na weight. So, W in water. Yan. Tapos, ang unknown natin ay yung buoyant force. Yan. So, wag muna kayong magpapanik. Kasi, ma'am, nasan po dyan yung density? Paano natin masosolve yung buoyant force? Okay. So, para na mahanap natin yung buoyant force, gagamit tayo ng free body diagram or FBD. Yan. Free body diagram. Yan. Para sa mga hindi familiar sa free body diagram or FBD, yung free body diagram, sorry, namatay yung ilaw ko. Yung free body diagram ay drawing natin to visualize the direction of the forces acting on an object and then kung ano yung magiging direction nung resulting force. Okay? Yan. So, drawing lang tayo sa free body diagram. So, the free body diagram consists of the Cartesian plane. So, magdodrawing tayo ng Cartesian plane. Wait lang, I'll use black. Yan. So, syempre, dito yung Y, dito yung X. Ayan. Tapos, yung object natin, i-place natin at 0, 0. So, andito yung object natin. Ayan yung solid metal block natin. Ayan. Tapos, sabi natin, di ba, yung solid metal block natin, it has a downward force acting on it, which is its weight. Tama? So, meron siyang downward force. Yan, drawing tayo ng arrow pababa. So, this stands for the weight of the object. Tapos, sabi rin natin, merong buoyant force na nag-a-act dun sa block, di ba? So, yung buoyant force, ang direction niya ay upwards or pataas. So, drawing din tayo. But since sabi natin yung solid metal block ay nakasubmerge or nakalubog sa liquid, that means yung arrow natin for the buoyant force ay shorter than the arrow for the weight. Kasi nga, since nakalubog, less than yung FB dun sa weight, di ba? So, sa tingin nyo, anong arrow yung matitira? Anong direction ng arrow yung matitira pag pinag-minus natin to, yung distance nila? Sa weight nung object. So, yung arrow ay pababa. Yan. So, this would be our net force. Or, yan, Fy. Okay. Now, syempre, hindi pa dyan nagtatapos. I-express pa natin to mathematically. Okay. So, sabi natin, meron tayong net force sa Y. May net force tayo. And yung net force na yun ay equal sa, yan, pag net, ibig sabihin, or pag sum nung Y forces, ibig sabihin ay nag-a-add tayo. Kasi nga, sum. So, meron tayo nung FB plus yung weight of the, meron tayong FB plus yung weight of the object. But since downward itong weight of the object, that means it is positive or negative? Negative. So, lagay natin. Weight of the object. Ayan. So, we have to note na yung weight of the object ay equal dun sa weight niya kapag nasa air pa lang siya. Okay? Kapag hindi pa siya nakalubog sa fluid or dun sa water. Yung weight ng object ay equal dun sa weight niya sa air. And then, yung weight, yung Fy or yung net force ay equal sa weight nung metal block in water. Yan. So, ito yung nare-read nung ating scale. Okay, ma'am, bakit po weight in water? Yung sum of the forces. Kasi, di ba, yung nasusukat na nitong spring scale natin ay kapag nakalubog yung metal block sa water. So, that means meron ng dalawang forces na nag-a-act dun sa metal block. Yung dalawang forces na yun ay yung weight of the object at saka yung buoyant force. Kaya, yung weight in water ay equal na dun sa sum of the forces in the y-axis. Okay? Kasi, pag nasa air pa lang siya, hindi pa siya nakalubog sa fluid, ang nag-a-act lang sa kanyang force ay yung weight niya mismo. Okay. So, now, we can transform this equation using these values. So, papalitan lang natin. W, water, yun yung ipapalit natin sa sum of the forces in the y-axis. And then yung FB plus yung air. Or yung weight ng air. So again, siya ay negative. Tapos, if you can notice yung yung sum of the forces in the y-axis, it is also downwards, di ba? So, that should also be negative. Yan. So, lalagay tayo ng negative sa weight ng water. Now, meron na tayong equation for buoyant force. Well, actually, hindi pa. Kasi, syempre, need pa nating i-isolate tong FB. Pero, malapit na tayo. Diba? Kikita nyo na ba ang liwanag? Yan. So, from this equation, we need to isolate the buoyant force. So, to do that, anong gagawin natin? We just add positive W air to both sides of the equation. So, hindi na kasya sa papel ko. Pero, we just need to add W air sa both sides ng equation. Yan. So, negative plus positive ay equal to 0. So, negative W air plus positive W air is equal to 0. So, makakancel siya. Tapos, meron na tayong derived formula for buoyant force. So, this would be buoyant force is equal to the weight of the object in air minus the weight of the object when it is submerged in water. So, yay! Meron na tayong formula for buoyant force. Yan. So, isusulat na natin yung equation na yun. FB is equal to the weight of the object in air minus its weight on water. But, hindi pa dyan nagtatapos. Ma'am, wala naman po tayong given na weight of air. Okay, wala nga. So, kailangan pa nating kunin or i-compute yung weight ng object habang siya ay nasa air. But, madali na lang yon kasi meron na tayong mass ng object, diba? So, recall that the weight is equal to mg. So, we could transform this equation as m air plus g is the acceleration due to gravity, which is a constant. Tapos, weight in water. Yan. Okay, class. Ano ulit yung value natin for g? Ano yung value natin for the acceleration due to gravity? Okay, very good. So, 9.8 meters per second squared. So, constant yan ha. Constant meaning hindi nagbabago. So, now we can solve for the buoyant force. So, sabi natin, yung mass nung solid metal block ay 5.4 kilograms. And then yung acceleration due to gravity ay equal to 9.8 meters per second squared. And then, ima-minus natin yon or isusubtract natin dun sa weight of the water, which is 34.8 newtons. Yan. Again, huwag kayong mababahala kung magkaiba yan, kung kg ms squared dito, tas newton dito. Kasi, if you can recall, Newton is also equal to kg times ms squared. So, pag pinag-multiply nyo yung unit nito, tsaka nito, Newton lang din yung kalalabasan. Yan. So, uniform pa rin naman yung units natin all throughout the solution. So, plug this in to your calculators. 5.4 times 9.8 is equal to 52.92 newtons. And then minus 34.8 newtons. FB would be equal to, or the buoyant force would be equal to 18.12 newtons. Okay. Clear? Yan. So, ito lang din siya, yung FBD nung solid metal block natin. Yan lang din siya, yung drawing natin kanina. Mas maganda lang yung sulat at yung drawing. And then, ito yung solution din natin. So, same naman dun sa nakuha natin or na-compute natin kanina. Okay. So, next question ay yung number 2. What is the volume of the block? So, again, given muna tayo. Meron tayong given na FB. Ayan, nasolve na natin yung buoyant force. So, pwede na siyang gawing given. 18.12 newtons. Tapos, the acceleration due to gravity, which is 9.8 meters per second squared. And then, yung density of water. So, yung density of water, wala dito sa problem, pero constant kasi siya. Kaya, ayan, kaya hindi siya included. Hindi na siya usually sinasabi. Pero yung density of water natin, yung density of water natin ay equal to 1,000 kilogram per cubic meter. Okay. So, sulat lang natin. 1,000 kilogram per cubic meter. So, yung ano natin ay yung volume ng block. So, the equation that we need to use ay yung V is equal to FP over rho G. Okay? Ito yung na-derive nating formula kanina dun sa 4. Nakasunod pa? Okay. So, since meron na tayo nung lahat ng values, pwede na tayo direct substitution. So, V, yung buoyant force natin ay 18.12 newtons. Yung density or rho natin ay 1,000 kilogram per cubic meter. And then, yung acceleration due to gravity na, ms squared na agad. acceleration due to gravity na 9.8 ms squared. So, para makita nyo yung cancellation natin ng units, tatransform lang natin tong Newton dun sa kilogram times ms squared. Okay? Para lang ma-appreciate nyo yung cancellation of units. So, 18.12 kilogram times ms squared. So, 1,000 times 9.8 is equal to 98, diba? 1,800 kg per cubic meter times ms squared. Ayan. So, magka-cancel na tayo ng units. So, we can cancel this ms squared tsaka tong ms squared since pareho lang naman sila. And we can also cancel this kg at this kg. Okay? So, that leaves us with this unit, cubic meter. So, solve lang din natin. 18.12 divided by 9,800. That would be equal to 1.8489 and so on times 10 raised to negative 3 cubic meter, or approximately equal to 1.85 times 10 raised to negative 3 cubic meter. Yeah. So, yun yung volume ng ating solid metal block. So, tama naman yung volume natin. Ang standard unit for volume ay cubic meter. So, let's check if tama yung pinaggagawa natin. Ay, sorry. Okay. So, tama naman. 1.85. Yan. Okay, so huwag kayong mabiglahan. I-round up ko lang yung dito. Since 1.848 siya, tapos gusto natin ay 2 decimal points, edi since 8 to, ra-round up lang natin yung 4. Kaya 1.85. So now, number 3. Ito na. Sabi niya, using yung answer natin for number 2, hahanapin natin yung density ng metal. Density ng metal. Tapos, based on that density, kailangan natin i-identify kung anong kind of metal ba siya. Okay? Kasi sabi lang sa problem, isa lang siyang solid metal block. So, we need to identify what kind of metal it is using a given density table. So, ibibigay namin yung density table. Tapos, dun yung hahanapin kung anong metal siya. So, let's start. So, ang hahanapin na natin muna ay yung density ng metal. So, ang given natin, we have the volume, which is equal to 1.85 times 10 raised to the negative 3 cubic meter. And then, yung mass ng object, which is 5.4 kilograms. So, yung unknown natin ay yung density. Yan. So, notice na yung unit natin dito sa density ng water ay kilogram tapos per cubic meter. So, yung kilogram, unit siya for what physical quantity or physical variable? Unit siya for, very good, it is a unit for mass. Tapos, yung meter cube or yung cubic meter, it is a unit for, okay, very good. So, yung cubic meter is a unit for volume. Diba? Yan, cubic meter, volume. So, that means, yung formula natin for density could also be M over V. Yan. So, you see, from the unit, nakaderive tayo ng formula. So, amazing. Okay, so yung equation natin ay ito. P is equal to the mass of the object over the volume of that object. Yan, para lang malinaw, de-define lang natin. So, since meron na tayo nung dalawang given na yan, pwede na tayong direct substitution. So, yung mass ng object again ay 5.4 kilograms. At yung volume ng object ay 1.85 times 10 is to the negative 3 cubic meter. So, plugging this in to your calculators, what would be our answer or what would be our density? Okay. So, our density would be 2.92 times 10 raised to 3, positive 3 kilogram per cubic meter. Or baka meron kasi sa inyong may calculator nyo na nagsagot na ganito. Yan, so okay lang din naman yan. Pero ayan, nag-scientific notation lang ako kasi para hindi siya masyadong mahaba, and since may scientific notation tayo dito sa ating problem. Pero valid din naman tong decimal form niya. Hindi naman yan mali. Okay. So now that we have the density of the object, pwede na nating hanapin kung anong kind of metal ba siya based on our density table. So tandaan nyo yung density ng object natin. Then let's look at the density table. So, if you can recall, ayan, meron tayo dito. So, sa scientific notation lang natin siya. Yan. To transform from decimal form to scientific notation, ito lang, i-move nyo lang tong decimal point papunta dito. Yan. Move nyo yung decimal point papunta dun sa gitna nung first two numbers. So, 1, 2, 3. Tapos, bibilangin nyo kung ilang places kayo nag-move. Okay? So, dito, since 3 siya, tapos nag-move tayo to the left, magiging positive siya. Okay? Kasi kapag nag-move, pag scientific notation na yan. Okay, so 2.92. Yan, round up tayo. Times 10 raised to 3. Yan, baka sabihin nyo, ma'am, bakit hindi po negative? Nag-move tayo to the left. Kasi pag yung SN natin ay ginawa naman nating decimal form, mag-move naman yan to the right, diba? So, bali kapag decimal form to scientific notation, kabaliktaran lang. Pag nag-move ka to the left, positive. Tas pag nag-move ka to the right, negative siya. Okay? Again, kabaliktaran kapag DF to SN or from decimal form to scientific notation. Yan. So, positive siya. Kilogram per cubic meter. Ayan. So, now, hanapin natin kung saan pinakamalapit itong computed value natin. Saang theoretical value. So, based on this density table, siya ay pinakamalapit itong 2.92 sa aluminum. So, yung value natin for aluminum, yung density niya daw ay 2.7 times 10 raised to 3. And then, yun na yung pinakamalapit kasi yung mga sumunod ay masyado ng mataas or masyado ng mababa. So, therefore, we can conclude that the solid metal block is most likely aluminum based on the calculated density after comparing it to the theoretical densities of the metals. Okay. So, is that clear? Yan. I hope that's clear. Ayan. So, yun lang yung problem natin for Archimedes Principle kasi we figured na that was too difficult. Ayan. Medyo difficult siya kasi ang dami nating kinuha. Kumuha tayo ng buoyant force, ng volume, ng density, tapos nag-identify pa tayo ng metal based on dun sa density na na-compute natin. So, you can go through that problem again. Try to do it on your own para mahasa nyo or ma-practice nyo yung pagsosolve sa mga ganong problems. And then, you can look up similar problems online. So, I highly recommend si Organic Chemistry Tutor. Yan, search nyo lang Archimedes Principle, tas Organic Chemistry Tutor. Nagbibigay siya ng maraming sample problems and then also solution and answers. So, very helpful siya. Okay. So, now, yung last part ng lesson natin is just applications of those two principles in various contexts such as home, community, businesses, and transport. So, sa home, using a bathtub. What will happen when you step in a filled bathtub or drop an object like a rubber duck? So, ano mangyayari? Based on Archimedes Principle. Okay. So, aapaw yung bathtub natin kasi magdi-displace tayo ng fluid. Yan. Tas puno siya. Yan. So, this will help us understand how ships float or how to measure volume using displacement. Then next, sa community naman ay water towers and water distribution sa Pascal's Principle. So, how will you describe your local water tower system and how it supplies to water homes? Yan. So, Pascal's Principle explains how pressure applied at one point in a confined fluid is again transmitted equally throughout that fluid. So, this allows water to be delivered evenly in a community. Next, sa business ay yung hydraulic presses natin or hydraulic machines. So, again, application siya ng Pascal's Principle. More specifically sa mga paglift ng heavy objects, 'di ba? Yung hydraulic pistons natin, that's an application of Pascal's Principle. And then, meron din tayong Archimedes Principle sa ship and boat design. Ayan, so, alam naman na natin to kung paano siya nagwo-work using Archimedes Principle, 'di ba? Mas mataas yung, or equal yung buoyancy or yung buoyant force natin to the weight of the ship. Kaya siya lumulutang. And then, here, Pascal's Principle, hydraulic rescue tool. So, how will you describe the structure and use of the device? Yan. So, nag-a-apply siya ng great pressure yung ating tool to allow cutting or prying open of metals, which can't be accomplished by normal tools. So, commonly used siya ng mga firefighters natin during life-saving operations. So, that's it for our lesson on fluid mechanics. And dahil nakarating kayo sa dulo ng ating lesson, meron akong good news. Okay, pag maaga niyong natapos itong video na to, you can use the remaining time for your PBT, for the making of your PBT, and then yung announcement ko is that na-move yung deadline natin for PBT. So, nabanggit ko naman na, okay, sa isang section ko lang to nabanggit, sorry. So, ayun, yung deadline natin for PBT will be moved to next week. Okay. So, kailan next week, ma'am? Depende yon sa section nyo. So, sa schedule ng section nyo pala, sorry. So, for example, For S11-16, yung magiging deadline ng PBT nyo ay sa Thursday during our 1-hour class. Okay. So, dun tayo sa 1-hour schedule nyo magpre-present at magpapasa ng PBT. So, again, for S11-16, yung deadline ng PBT nyo ay next week. Ay, wait lang. Sorry. Holiday ng Thursday, hindi kayo makakapagpasa. Yung deadline ng PBT for S11-16 ay next week, Wednesday, during our 2-hour class. Okay? Okay. For S11-11, the deadline of your PBT would also be Wednesday next week during our 1-hour class. And then for S11-15, the deadline for your PBT would be on Friday during our 2-hour class. So, since Thursday din natapat yung 1-hour class nyo, we can't meet. So, for S11-15, that would be, your deadline would be on Friday. Ayan. So, happy making of your PBT and good luck. Bye-bye!